Welcome to solverfy.
Hello everyone. Today we are learning more about motion in one dimension. This is probably one of the trickier problems and a little bit more time consuming, but it's worth it. So our problem deals with a car and bike starting at the same time. We want to know how long the bike's in front and what's the max distance the bike's in front of the car, how in front of the car for. So the first thing we need to do is figure out how long it takes the bike to reach its maximum velocity. And we do this by looking at this equation right here. These are two of the four kinematic equations that you can find in any intro to physics textbook. So by using this equation, it says that the final velocity is equal to the initial velocity plus the acceleration times the time. Well, in our case, we know, given from the problem, that the final velocity of the bike is 20 miles per hour, and this equals the initial velocity is 0 because it started from a stopping point. So the acceleration, it tells us, is 13 miles per hour per second, and we don't know t. So we're just going to divide 13 on both sides, and we get that the time it takes for the bike to reach its maximum velocity is about 1.538 seconds. I can write that a little bit better. 8 seconds. And now, in order to figure out how the maximum distance between the car and bike, we need to figure out how far they have traveled. Because at this point, the bike has stopped accelerating, but the car is still accelerating. So the distance after 1.5 seconds is going to decrease. At this time, they are the maximum distance away from each other. So in order to figure out the distance that the bike has traveled, we are going to use the top equation that says that the distance x is equal to the initial distance plus the initial velocity times time plus 1/2 acceleration times t squared. Well, in the problem, the acceleration is given in miles per hour per second. We want to trim this down into feet per second. It gives us a little more recognizable numbers. So in order to do that, we have to do some unit multipliers. So A is equal to, the bike is accelerating at 13 miles per hour per second. Well, let me change that to miles. In order to change this to feet per second, we have to use some unit multipliers. So we're going to multiply this by, there's 1 hour in 3,600 seconds. That takes care of the hours. And now we want to convert miles into feet. So we multiply it by 5,280 feet per mile. The miles cancel. So now we have 13 times 5,280, all divided by 3,600. This gives us the acceleration for the bike in feet per second squared, and this equals 19.067 feet per second squared. That's our acceleration for the bike. And now we can plug this acceleration into this equation to calculate how far the bike has traveled. Just going to clean up some workspace here. I rounded to 3 decimal places, but whenever you get your final answer, make sure that you keep all of your decimal places. We round off just to save a little bit of space on paper. So plugging this into this equation, we get that the distance the bike has traveled is 0 because it started from a stopping point. Or we're going to say that the initial point is where the car and bike started. Its initial velocity was 0, so it's going to be 0t plus 1/2 times 19.067 times t squared. In this case, t is the 1.538 seconds squared. And this tells us that the bike has traveled 22.564 feet. So now we know how far the bike has traveled in this span. Now we want to know, well, how far back is the car? And the difference between this 22 feet and the car's distance, how far the car has traveled, will be our maximum distance between the two for this problem. So now, using the same equation, this one right here, we're going to figure out how far the car has traveled. So, clean up our workspace. They start at the same point, which we're going to say is their starting point, so it's 0. It started from a stop, so its velocity is 0, plus 1/2. The acceleration for the car is given as 9 miles per hour per second. You can go back and look at the unit multipliers we did earlier to convert to feet per second. So this would be 9 times 5,280 divided by 3,600 times 1.538 squared. And this gives us that the distance the car has traveled in this time is 15.621 feet. Now we know that after 1.538 seconds, the bike has stopped accelerating, but the car is still accelerating. So now the distance between them is only going to get shorter until the car passes it. So at 1.538 seconds, the bike and car are at their maximum distance away from each other. And to calculate it, we just subtract how far they've gone. So if you remember, the bike had traveled 22.564 feet. Now if we just subtract this, we will get that the maximum distance between the bike and car throughout this problem was 6.943 feet. That's our first answer. Now we want to know, how long is the bike in front of the car? Well, whenever the bike is no longer in front of the car whenever the car passes it. At this point, the car and bike are at the same position. So we can use this top formula again. So at some position, we're going to have the bike's initial position plus its velocity times t plus 1/2 at squared of the bike. This is also going to equal the initial position of the car plus the car's initial velocity plus 1/2 a car t squared. because they'll be at the same point in space, these two equations equal each other. Now, we have the initial position of the bike, which is the 22.5 feet. We don't know its velocity in terms of feet per second. We know it's not accelerating anymore, so this term is going to go to 0. We have the car's initial position, the 15.5 feet. We don't know its velocity in feet per second, so we'll need to calculate that. And it's still accelerating, so we are going to have the full 3 terms on the right-hand side. So in order to solve how much longer it's going to take for the car to pass the bike, we need to figure out VB and VC, the velocities at which the bike and car are going respectively. And we figure that by this equation right here. So we want to know their velocities at the point the bike reaches its maximum velocity. So we already found the acceleration for both the bicycle and the car and their initial velocity was 0 from the starting point. So we're just going to multiply their acceleration times the time at which the bike reaches its maximum velocity, which is 1.538 seconds. And I'll just give you to those there. So it would be V of the bike is equal to 13 times 5,280 all over 3,600 times t, which in this case would be 1.538, and this equals 29.333 feet per second. In a similar way, just replacing that 13 with a 9, the velocity of the car would be 20.307 feet per second. Now, we can just plug this into this equation and solve for t. So let me go ahead and clear up some workspace. And whenever we plug in everything, after you plug in everything and move it all over to one side, you should get that 0 is equal to 33 over 5 reduced t squared minus 9.026 t minus 6.943. And as you can obviously see, this is going to be a quadratic formula equation. You can plug that into the quadratic formula, and we will only take the positive t because time is never negative. And after you plug that in, you should get that t is equal to 1.916 seconds. Now this is how long it will take the car to take over the bike from the point whenever the bike reaches its maximum velocity. And so we have to add how long it took the bike to get to its maximum velocity, which would be 1.538. Add this up, you get about 3.5 seconds. So it takes, from start to finish, It takes the car about 3.5 seconds to completely pass the bike. And the max distance between those is whenever the bike reaches its maximum velocity, and the distance between them is about 7 feet. These are our answers.